In today's video, we will be discussing Physics 251 Week 7 Video Explainer problem number 41. In this problem, we are tasked with relating some of the forces for our given system, which has a book sliding on a table, a slanted table, and a cup on a string, which is attached to the book. So for this problem, if anything I say seems unclear, I would recommend going back to the Week 7 lecture notes, specifically pages 27 through 45 deal with tension, and I think you would get a lot of help from that. So I've gone ahead and underlined some of the givens here in the problem. We can see that we have factors such as weight, coefficients of static and kinetic friction, as well as the speed of the book in this problem. So I've gone ahead and written those all down here, as well as some formulas that I think would be helpful, specifically the kinematics equation right here. We have the equation for the force of friction, and of course Newton's second law here. So to go ahead and start the problem, I thought it was helpful to draw a kind of diagram relating some of these forces and how they might interact. So as you can see, we have our frictional force here, we have our book sitting on the slant with our force due to gravity as well as our normal force, and then we also have our cup of coffee, which has been reduced to a box, and we have some of the tension forces associated with that, as well as the force due to gravity that's pulling the cup downwards. So to go ahead and start this problem off, I ended up writing up some relationships between the forces on the book and the forces on the cup of coffee. As you can see here, I have these two equations relating Newton's second law, in which we have our forces here and then our mass times acceleration, and we have our forces here and our mass times acceleration. So from here, it's important to find our acceleration, because we want to know how far the book slides, and we're going to need acceleration to do that. So here I'm relating the two equations together and simplifying down, and then I get this expression here for our acceleration. With this expression, I'm going to just plug in our variables, as you can see here, and I am left with 6.736 meters per second squared. And then from this acceleration here, I actually need to plug it into our kinematics equation up here to get our distance. So this is how far the book slides right here, 0.668 meters. For the next part of the problem, it's a little bit more conceptual, but we're still going to be using some of these same equations that we were using before. So for this second part, we need to figure out initially the force that's required to hold the cup at stasis. So by solving for tension here, we're able to get that the cup requires 4.9 newtons. From here, we can actually plug our 4.9 newtons into the equation for the book right here, and we are left with 8.25 newtons for the tension in the system. And then next, we're tasked with using the static friction here, so we're going to be talking the coefficient of static friction, and we're going to need to figure out what the force, or what force is required for the book to remain static, the cup to remain static, excuse me. No, the book to remain static, sorry. And so from here, we can relate the two forces from the system and the book remaining static. And since the force of the system is so much greater than the static force of the book is going to end up sliding back down the ramp. All right, well, thank you very much. I hope you all found this video helpful. Have a great week.